Hello my dear friends, I welcome back you to my YouTube channel, that is Beginners Chemistry, where you can learn the chemistry in the easy manner. In our last class of the solutions 1, already we have discussed about the which one? Introduction of the what is the meaning of the solutions, and we have studied about the some, not all the concentration terms, basic concentration terms we have studied. Now in this lecture, we are going to study very important concentration terms and their interconversions, how it is useful for us in the calculation purpose of our solution chapter, and not only it will be useful for us in the solution chapter, already they have studied this in the which one in the first year chapter of the mole concept or the redox reaction, but even though it will be helpful for us in the calculation purpose of our solutions. Now how it will be helpful? Now each and every term of the concentration term that I will derive and interconversion between them I will derive, clear? And after that we will do the how the questions and this year of 2025, and from these interconversions we got 2 to 3 questions. Same this interconversion questions only, whatever the concentration terms we are going to deal here, from these interconversions they have asked the 2 questions, and what they have asked that also we will solve, and the other questions also we will solve. Clear? Now let's start our lecture. Before starting the our chapter or solutions lecture 2, once I want to recap what we have studied in our last class. Okay, very quick recap I will give you and we will start our lecture. Now in the last class what we have studied? We have studied what is the meaning of the solution? Solution is nothing but solute plus solvent gives rise to solution, right? Clear? Now which type of the solutions we are going to deal? Homogeneous mixture, right? Or homogeneous solution, right? And already I said you homogeneous solution. What is the meaning of the homogeneous? Homogeneous particles or homogeneous particles which are present in the solutions we can't see. Clear? Why? That particle size is 10 to the power minus 7 centimeter or 1 nanometer. Clear? 1 nanometer. Done. Next, here how to identify solute and how to identify the solvent. Clear? How to identify the solute and how to identify the solvent, that we have seen. Solute means which contain less quantity. Now solvent which contain less quantity. This is which contain high quantity. Clear? Okay. Here this is a quantity which contain less quantity. Clear? Done. Next we have studied what we have studied. We have studied about the dilute and the concentrated. What is the meaning of the dilute? Dilute means less solute particles in the solution. Here what is the meaning of the concentration? More solute particles. Clear? Now already I explained the general life example of the dilute and the concentration. What? That is lemon, right? If you take the lemon and if you cut, clear, and if you squeeze the lemon, starting of the lemon will be the concentrated. If you add the water, what happened? The concentration of that lemon will be decreased and that it will become dilute. Clear? And next we have studied about the which one? That is unsaturated and saturated and super saturated and super saturated. Clear? Now what is the meaning of the saturated? More the solute. If you take the solvent or if you take the water and if you add the solute, what it will happen? That solute will be dissolved in this solvent. That type of the solutions we call it as a unsaturated solution. More the solute can be dissolved in the which one? In the solution or in the solvent is known as a unsaturated solution. Comes to the saturated solution. What is the meaning of the saturated solution? Already I explained you. Saturated solution means dissolution, means the salt is completely converting into the solution or completely converting into the solution, and equilibrium with the crystallization. What is the meaning of the crystallization? Whatever the solute particles has been dissolved in the water, that again it is converting into the solute particle is known as a crystallization. Clear? Salt is converting into the solution, and that converted solute again it is converting into the solute particles. Clear? When these two is happening, that type of the solution we say it as a saturated solution. Sir, I did not understand, sir. Can you explain very clearly with the another example? Okay, now see. Saturated solution means if I take something 30 ml of the water. 30 ml of the water I was taken, or better I will take 1 liter of the water. 1 liter of the what I was taken? I was taken the 1 liter of the water. 1 liter of the water I was taken. When I was taken the 1 liter of the water, what? When I was taken the 1 liter of the water, this 1 liter of the water, first I was added the 10 mole of solute. Some weight of the solute I was added. What did happen? This solution has dissolved that solute. Okay? Then that solution we call it as a unsaturated solution. Again I was increased to the 20. Again it has been dissolved. Clear? Then I was taken the 30. What it has happened? That 30 moles of solute when I was added, what it has happened, you know, that solute particle is settling down here. But before 30 up to 29 moles is converted into the solution, right? That converted into the solution. When you add the 31 mole of that solute, what it is happening, you know, the solute particle which has been converted into the solution, again it is converted into the solute. Means same amount. One is converting into the solvent, or one is converting or dissolving in the solution. One which has been dissolved in the solution, again it is converting into the solute in this manner. One is dissolving, one is again it is converting into the solid. So that's the reason this is dissolution is equilibrium with the crystallization, and that type of the solution we call it as a saturated solution. Okay. Now what is the meaning of the super saturated solution? Whatever the solute that has been dissolved in the here, one solute has been dissolved in this solution. That dissolved solute, what it will happen? Again it will be converted into solute particle like this. Clear? That solution we call it as a super saturated solution. Clear? Then after that we have seen some types of the solutions we have seen. Gas in gas, and how to identify which type of the solution, that we can decide it on the basis of the solvent nature, right? That we can, which solution we can say. If suppose I was taken the salt or sugar, I will take better well known example for you. Sugar. What is the sugar? Sugar is solid. And H2O. H2O is a liquid, right? H2O is a liquid. H2O is our solvent. Then that solution is solid solution or liquid solution. Already I explained very clearly. If the solvent is present in the liquid nature, and that solution we call it as a liquid solution. Let's suppose one solute I was taken. Okay, and one solvent I was taken. Clear? If this solvent is gaseous in nature, if solvent is gaseous in nature and that solution is gaseous solution and that solution is gaseous solution. Clear? Now if solute plus solvent, if this solvent is solid, if this solvent is solid, then that solution is solid solution. That solution is solid solution. Clear? Liquid solution, gaseous solution and the solid solution. Is it clear? I hope it is clear for you. Done. Then after that, next we have studied the concentration terms, right? What are the concentration terms we have studied? What are the concentration terms we have studied, Amma? One is weight by weight percentage and volume by volume percentage. Clear? Now you see here, first concentration term we have studied, weight by weight percentage. What is the weight by weight percentage? Weight of solute in grams by weight of solution in grams into 100 into 100. And one very important point I was explained for you and I said you to remember also, weight of solution. This point we will use in our interconversions. This will play very crucial role. So weight of the solution will be equal to weight of solute plus weight of solvent. Clear? With the temperature, weight of the solution will not change. That also I explained you very clearly. With the temperature, weight of the solution will not change. Only which will change? Volume of the solution will be changed. If you heat the volume will be converted into the gases. So volume ml will be decreased. But weight of the solution, there is no any change. Clear? Now, next we have taken, this is temperature independent. This is temperature independent. It will not depend upon the temperature. Next we have studied V by V percentage. V by V percent. What is the V by V percentage? Volume of solute in ml by volume of solution in ml into 100 into 100. Clear? This one, volume of the solution is equal to volume of solute plus volume of solvent. This is applicable only for the ideal solution, that I was explained very clearly. Why it is only for the ideal solution, I will explain in this chapter itself when we start the Raoult's law. Okay, in this chapter itself we are going to start the Raoult's law. There I will explain why only the volume of the solution will be volume of solute plus volume of solvent. I will explain, don't worry. Okay, now this is temperature dependent. Why it is this temperature dependent? Why it is a temperature dependent? Because it is depending upon the volume. Done. Next we have studied, what we have studied? W by V percentage. W by V percentage. What is the W by V percentage? Weight of solute in grams by volume of solution in ml into 100 into 100. Here weight by volume percentage, here I was explained one interconversion. If you remember this interconversion, in the calculation purpose of our question, there we will not get any mistake and very fastly we can do the calculation. What is that interconversion? Now we'll see. Clear? Now weight by volume percentage is equal to weight of solute, right? This is weight of solute in grams. Volume of the solution. What is the volume of the, first we'll go with the density. What is the density formula, ma? Density of solution is equal to weight of solution by volume of solution. Clear? If I take the volume of solution to the left hand side, volume of solution will be into volume of solution will be equal to weight of solution by density of solution. Density of solution. Same thing, this volume of solution, can I substitute here? Can I substitute here? Then what it will become? Weight of solute in grams is equal to weight of solution by the density of the solution, right? This density of the solution here 100 into density of the solution, can I write? Density of the solution. Clear? Now you see, this is weight of solute in grams and the volume of solution into 100. Volume of solution into 100. Then W by V percentage will be equal to, can I say, W by W percentage into density of the solution. Density of the solution. This is very one interconversion that we are going to remember. W by V percentage is equal to W by W percentage into density of the solution. Density of the solution. Clear? Next after that, one very important that we have studied. What is that? Strength of the solution. Strength of the solution. Strength of the solution. What is the strength of the solution? What is the strength of the solution? Strength of the solution means, here only one thing you have to remember. Strength of solution is equal to weight of solute in grams by volume of solution in liter. In 1 liter of the solution, how much weight we are having, that we call it as or how much strength of our solute it is having in the 1 liter of the solution is called as the strength of the solution. Is it clear? Done? Now, can I modify this formula in this manner? Weight of the solute we used to represent in the B, right? So, weight of the solute by volume of solution into 1000, because I was converted this unit in the ml. Clear? I was converted this unit in the ml. So can I say like this? Weight of solute B, or weight of the solute by volume of solution in ml into 100 into 10, can I write? This 1000 can I write into the 10, 100 into 10 for our mathematical calculation purpose. So weight of the solute by the volume of the solution in ml into 100, that what is that one? Just now we have studied, that is W by V percentage, right? W by V percentage into 10, can I write? So this we are going to use. This we are going to use in the with the relationship with the molarity. With the relationship with the molarity. Clear? And the next we have studied about the ppm and the ppb. What is the ppm? 1 gram of the solute or 1 mole of the solute that is present in the 10 to the power 6 of our solution or in the solvent. Clear? That is known as the ppm, and the ppb is 10 to the power 9 billion. Done? Now we are going to start our today's lecture, and this is very important. That is first interconversion that we are going to see. Based on this interconversion only, 2025 in the JEE mains we got the we are having the different shifts, right? In the overall shifts we got the 3 questions by relating with the molarity and molality, and relating with the molality and the mole fraction, and the using of the normality, and this interconversion mole fractions. Here first we are going to deal with the molarity. Okay, molarity we will represent with the capital M. Okay, now what is the meaning of the molarity? What is the definition of the molarity? Clear? Definition of the molarity is number of moles of solute present in 1 liter of solution. 1 liter of solution. Clear? 1 liter of solution is known as the molarity. So generally if I want to represent the molarity is equal to number of moles of solute, number of moles of solute by number of moles of solute by V liters, can I write? V liters, can I write? Number of moles of the solute in the V liters. Clear? Now if I ask what is the units of the molarity? Number of moles is mole, unit is a mole, and the volume is a liter, or we can say mole liter inverse or mole per liter. This is a unit of the molarity. This is temperature dependent or temperature independent. You can see, you are seeing the volume term. Already I explained you, if you see the volume term in the any concentration term, that it will change with the temperature, right? Clear? This is temperature dependent. Clear? Now here what we are going to see, molarity, this is a formula. Now what are the extended formulas? Whatever the formulas I was extending here, if you remember that formulas, by seeing that formulas or by seeing the question data, if you use these formulas directly, you can get the answer by using or whatever the expanded formulas I was giving here. If you remember and if you put it in the, or if you apply to that question directly, you will get the answer. And by using that formulas, we will do the questions also. I brought the n number of questions, you can see. Clear? Now here the n number of the questions I brought, different questions I brought. Okay, now we'll see, don't worry. Okay, now first expanded form of the molarity, m is equal to n by v l, right? This is first. Second one, we can expand this molarity. This is which one? Number of moles of solute. This is solute, don't get confused. Solute, this is volume of solution in liter. I want to convert this volume of solution or volume of the solution is in the ml, right? I want to convert it into ml. So NB, so this one will be the VML into 1000. Clear? Done. Still I want to extend this formula. Number 3, molarity is equal to number of moles of solute will be weight of solute by molecular weight of solute into 1000 by volume in ml. So many of the questions they are asking, they will ask you the weight of the solute. They will give you the molarity and they will give you the VML and they will ask you the weight of the solute. How to calculate the weight of the solute? Weight of the solute is equal to molarity into molecular weight of solute into VML by 1000. Clear? This is a which one? Weight of the solute if they ask. Next one, here the next formula we are going to derive. Now listen carefully. Here you will get somewhat confused. Now listen carefully here. Now fourth formula we are going to derive, that is here molarity is equal to weight of solute. This is weight will be the units will be in the grams, right? Weight of solute in the grams by here this volume of the solution is in the ml, right? Volume of the solution is in the ml. Here we are having the 1000 into 1000 into molecular weight of solute. Can I write? Molecular weight of the solute, can I write? Done. You can see here. Okay, better I will expand here. This formula I was writing in this manner: weight of the solute in grams by volume of the solution in ml into 1000. This is 1000 into by molecular weight of the solute. Clear? Now here this one molarity is equal to where we have seen this one, weight of the solute in grams by volume of the solution in ml into 1000. This is the strength of the solution, right? Strength of the solution. This is strength of the solution, right? Strength of the solution by molecular weight of the solute. Molecular weight of the solute. Can I write? Molarity is equal to strength of the solution by molecular weight of the solute, right? Molecular weight of the solute. Now you can see, just now I was discussed here the which one? Strength of the solution formula. Where? Now you see, strength of the solution, weight of the solute in grams, or weight of the solute by volume of the solution in ml into the thousand is a strength of the solution. Same thing here also. You can see, weight of the solute in grams by the volume of the solution in ml into 1000 is a strength of the solution. And one conversion also we did in the strength of the solution case. What? W by B, volume of the solution, into 100 is a weight by volume percentage into 100. Weight by volume percentage into 100. Clear? Now based on this one, molarity is equal to strength of the solution by molecular weight of the solute, right? So can I write here? M is equal to strength of solution by molecular weight of solute. Molecular weight of the solute. Already strength of the solution we have derived here, right? What we have derived in the strength of the solution? Strength of the solution is equal to weight by volume percentage. Weight by volume percentage into 10. Weight by the volume percentage into 10. So can I write this strength of the solution in this manner? Molarity is equal to W by V percentage. W by V percentage. Clear? W by V percentage into what? Into 10. Into 10. W by V percentage into 10. Can I write? Done? Clear? Or else strength of the solution is W by V percentage into 10. That we got by molecular weight of B. That molecular weight of B. Here for this one I was derived the one formula. You see, in the starting itself I was derived here. What I was derived? Weight by volume percentage is equal to weight by weight percentage into density of the solution. Weight by volume percentage is equal to weight by weight percentage into density of the solution. So can I put that weight by weight percentage into density of the solution here? So molarity will be equal to what it will happen? Weight by weight percentage into density of solution into 10 by molecular weight of solute, right? Molecular weight of solute. Clear? This is the one very important formula we got. One very important formula we got, and we will do the many number of questions on this formula. Any number of the questions on this formula. Clear? Now we'll try to do one question. This is a one question that which we have derived the formula and we are going to see. See, a sample of H2SO4 density is 1.8 gram per ml is 90% weight. 90% weight is nothing but weight by weight percentage only. Clear? What is the volume of acid that has added to be used to make 1 liter of 0.2 molar of H2SO4? 0.2 liter of H2SO4 is asking. Clear? Molarity is equal to weight by weight percentage into density into 10 by gram molecular weight or molecular weight. Clear? By this, by using the data, what we will get? We will get the molarity. We will get the molarity. After getting the molarity, what is asking? What is the volume of acid that is added used to make the 1 liter of 0.2 molar H2SO4? Whatever the molarity we got here, that molarity will take it as a M1. Then we are going to use the formula M1V1 equal to M2V2. This M2 they have given 0.2 and V1 they have given 1. But they are asking in the ml, right? So 1 liter convert into ml. Then that m1 will come from here. How it will come? See, weight 1 by 18 percentage. Sir, 1 by 8. That weight how much again? 90. So 90 into 1.8 into 10 by 98 will be the H2SO4 molecular weight. Molecular weight. If you calculate, how much you will get? If you calculate how much you will get, that molarity you keep it here. That molarity you keep it here. That M1 you keep it here. And V1 you have to calculate. How to calculate? From this M1 we will get. So we are asking V1, right? V1 is equal to 0.2, sorry, that is 0.2 into 1000 by M1, which we got it by this calculation. And what is the answer you got? You just comment in the comment box. Whatever the answer you got here, that you just comment in the comment box. That V1 you will get. That V1 you will get. Clear? Now this is the question. This is the question. Now next another very important concentration term that we are going to study, that is which one? Normality. The next very most important concentration term that we are going to study, that is normality. Clear? What is a normality? Normality N is equal to equivalence of solute. Normality and molarity is same only. Molarity we are going to deal with the number of moles of solute. Here we are going to deal with the equivalence of the solute. That's it. By volume of solution in liter. Volume of solution in liter. Okay. This one what I was expressing. Normality is equal to number of moles of gram equivalents. Clear? Number of gram equivalents Ne by volume in liter. Volume in liter. Clear? Here the expanded formulas of the normalities it will make somewhat confused, but I will make you clear what are the expanded formulas of the normality it is having. If you remember these formulas, it is enough for you. It will be helpful for you in the calculation purpose of the redox calculation or titration calculation or titration questions, and as the same way it will be helpful for us in the solving of the solutions also. Clear? Now you see. Here this is a what? Equivalence of the solute by volume in liter is a normality. That I want to convert into the ml now. Normality is equal to gram equivalence or equivalence of the solute by VML into 1000. VML into 1000. Clear? I want to expand this gram equivalence formula. Clear? Or equivalence formula. Equivalence is equal to, what is the equivalence formula? Weight of solute by equivalent weight. Equivalence formula is weight of solute by equivalent weight. Here also one another formula is there. Sir, another formula? Yes, Nana. You have to remember. What is the another formula? Equivalent weight. Sir, what is the equivalent weight formula? Okay, I will explain. Equivalent weight is equal to molecular weight by n factor. Sir, what is the n factor? If it is a ions, charge on it ions will be the n factor. Sir, we did not understand. Okay, I will explain. Now you see. So, equivalence formula what you got? Equivalence is equal to weight of solute by equivalent weight. Clear? What is the equivalent weight formula? Equivalent weight is equal to molecular weight by n factor. Okay, I will do very beautiful and detailed lecture on the equivalent weight and the n factor. That video you go and see. Clear? Now, molecular weight by n factor. What here I will explain roughly what is the n factor. If I want to calculate the n factor of which one? H2SO4 and HCl. How many replaceable hydrogens we are having? That is the n factor for that one. Here the replaceable hydrogen for the H2SO4 will be, how it will dissociate, 2H plus SO4 minus 2. So here the two replaceable hydrogens we are having for the H2SO4, right? N factor of the H2SO4 is 2. HCl, how it will be dissociate, H plus and Cl minus. So replaceable hydrogens for this one, and the N factor is 1 and the N factor is 1. If suppose base they have given, NaOH and calcium hydroxide. Clear? If they have given, what is the N factor for this one? How it will be dissociate, Na plus and OH minus. Replaceable OH minus are 1. So N factor for this one will be the 1. Here the replaceable OHs are 2. So the N factor is 2. Clear? Done? In that manner we can calculate the N factor. Equivalence is equal to weight of the solute by equivalent weight. Equivalent weight is equal to molecular weight by N factor. Now, by using these formulas, we are going to expand this formula. How we are going to expand this formula? Now we'll see how we are going to expand. First one, what I am going to do, N is equal to, what is the equivalence formula? Weight of solute by equivalent weight, right? Equivalent weight into 1000 by VML. Done? Now I want to calculate the weight of the solute, and if they have given the normality and if they ask the weight of the solute, how to interconvert? Weight of the solute is equal to normality into equivalent weight into VML by 1000. Here this is a weight of the solute, we can calculate it from here. Done? Now here next here also we got what? N is equal to strength of the, from here I was calculating, strength of the solution by equivalent weight. I will get how, sir, how I got the strength of the solution and the by equivalent weight, sir? Now you see again same, W by G VML into 100 into 10 into 10. Can I write like this, right? That will be the W by V percentage into 10 will be the strength of the solution. W by V percentage into 10 will be the strength of the solution. Clear? Then can I write normality is equal to W by V percentage into 10 by equivalent weight. Done? This equivalent weight we can expand in the another way. How to expand? Already I explained you how to expand this formula. Done? This formula we can expand. Normality is equal to weight by weight percentage into density of solution into 10 by equivalent weight. Clear? This is a one very important formula we got. Weight by weight percentage into density of solution into 10 by equivalent weight. Clear? Now another type of the formulas. Now we'll see what normality we got. Normality is equal to weight percentage into density of solution into 10 by equivalent weight. Clear? And another some important formulas we are having for the equivalence. What are the some another important formulas we are having for the equivalence? You see here, equivalence is equal to normality into V in liter. Clear? This is equivalence. Milli equivalence. Milli equivalence means N into VML. Clear? This is one formula we are having. Next, another type of the formula we are having. What is the another type of the formula we are having for the equivalence? Normality equivalence is equal to NE equal to what we are having? What is the formula? Weight of solute by equivalent weight, right? Equivalent weight formula, molecular weight by n factor. Molecular weight by n factor. Weight by molecular weight is a number of moles. So equivalence is equal to what? Number of moles into n factor. Can I write? Number of moles into n factor. Can I write? Here you can see equivalence is equal to n into n factor we got, right? N into n factor we got. N into n factor when we got. Here this formula I was substituting in the normality. Normality is equal to what? Normality is equal to n into equivalence by volume in ml or volume in liter, right? If you want, you can see here normality formula. Where is the normality formula? Equivalence of the solute by volume in liter. So what I got? Equivalence is equal to n into n factor I got. So in the place of equivalence, n into n factor I was substituting by VML into 100. Sorry, VML into 1000. VML is nothing but normality is equal to molarity, right? Normality is equal to molarity, right? Into 1000. Okay, if you are getting confusion, I will write in this manner better. Here normality is equal to n into number of moles into n factor, right? Number of moles into n factor. So normality is equal to equivalence by which one? Volume in ml or volume in liter you take, better. So n into n factor by volume in liter. This volume in number of moles by volume in liter is a molarity. And this is also one very important, there is one very important relation that we are having. Equivalence is equal to number of moles into n factor. Normality is equal to molarity into n factor. This relation will play a very, very important role in identifying the solutions questions. Clear? Done? Now, this is normality is a temperature dependent or temperature independent. This is also, we have seen the volume term, right? So obviously it will be the temperature dependent. Clear? Now, next we are going to study very important one, that is molality. Molality that we are going to relate in our very important formula that we are going to study in our solutions. In our solutions, we are going to study one very important topic, that is a colligative property. There we are going to relate this molality only. So listen carefully and we will interconvert, or we will do the relationship between the molarity and the molality. Based on this only, this time in the 2025 we got the JEE Mains question. Now you see here, what is a molality? What is molality? Molarity is capital M. Molality is small m. Clear? What is the molality? Molality is nothing but small m. Now, what is the definition of the molality? Molality is equal to number of moles of solute by weight of solvent in kg. Number of moles of solute by weight of solvent in kg. This I want to convert into the gram. So number of moles of solute by weight of solvent. This is not the solution. Weight of solvent. Better I will write. Weight of solvent in gram into 1000. Clear? Now, can I expand this formula? Molality is equal to weight of solute in gram by molecular weight of solute B, molecular weight of solute B into 1000 by weight of solvent in gram, weight of solvent in gram. Clear? This is a one very important formula of the molality we are having, Clear? Now, molality is a temperature dependent or the temperature independent. What I said, this is which term? This is weight terms, right? This is weight and this is weight. So weight will not change with the temperature. This is temperature independent. Temperature independent. Clear? This you remember. This is temperature independent. Done. And the unit is molal. Clear? Or mole per kg. Done. Next one. Now here we are going to see very important conversion and the relation we are going to see. What is a very important and the relation that we are going to see? Listen carefully. Here, whatever the relation I was explaining, if you remember this formula, instead of expanding the data which they have given in the question, if you remember this formula, directly within seconds you will get the question. Now you see what is that we are going to study. Relationship between molarity and molality. We are going to see the relationship between molarity and molality. Here what I was taking, the which one? Molarity of the solution is M. I was taking molarity of solution, I was taking it as a M. Okay, molarity of the solution I was taking M. Then density of solution, I was taking some d gram per ml. I was taking. Now here I was considering molarity of solute are present in 1 liter. Clear? Now here if I want density of the solution, what is the formula of the density of solution? Density of the solution is equal to weight of solution in gram by volume of solution. Clear? Density of the solution. From here I can get volume of the solution, right? Volume of the solution will be weight of solution by density of solution. Weight of the solution, what I got? Weight of the solution by density of the solution. From this I can get weight of solution is equal to volume of solution into density of solution. Can I write? Done. Weight of the solution is equal to volume of the solution is equal to weight of solution by density of the solution. From here I got. So weight of the solution is volume of the solution into density of the solution. This is cleared. Clear? Weight of the solution I got. Now I will calculate which one? Now I will calculate weight of solute. Now what I will calculate? Weight of the solute I will calculate. How to calculate the weight of the solute? Molarity is equal to number of moles by volume in liter we are having. So if I expand this one, volume how much I was taken? 1 liter, right? So this one will be the molarity will be equal to number of moles. If I expand, that will be the weight of solute by molecular weight of solute. From here I will get the weight of the solute. If I take it to the left hand side, weight of solute will be equal to molarity into molecular weight of solute. Clear? Now from here what I got? Weight of the solute I got, and weight of the solution also I got. Weight of the solution. Weight of the solution. Weight of the solution is how much? Weight of the solution. Weight of the solution. Clear? Now here listen. This is weight of the solution. Weight of the solution. How much I was taken? Weight of the solution. Here weight of the solution I was taken the 1 liter, right? 1 liter. So this is in the form of the liter. So what I will do? I will convert this solution in the ml. If I convert this volume of the solution in ml, how much it will become? 1 liter of the solution. 1 liter of the solution will become 1000. Done. Into density of solution. Into density of the solution. Is it clear up to now? Is it clear? Now you can see here. Here the volume of the solution, how much we have taken? 1 liter, right? That 1 liter, here the volume of the solution density is, it should be in the ml. So liter I was converted into ml. So here it will become 1000. Density of solution is equal to weight of solution in gram by 1000. Done. Then weight of solution will be equal to 1000 into density of the solution. That only I was written here. Weight of the solution 1000 into density of the solution. I was explained one beautiful formula for you. What is that? Weight of solution is equal to weight of solute plus weight of solvent. Clear? Now by this formula, what we will get? Weight of solute we are having, weight of solution we are having, weight of solute we are having, weight of solution we are having. From here what we will get? Weight of solvent we will get. Weight of solvent we will get. Okay? Weight of solvent is equal to what? Weight of solution minus weight of solute, right? Weight of solution is how much? 1000 into density of solution minus weight of solute, how much I got? Molarity into molecular weight. Molarity into molecular weight. Clear? Now done. Our formula has came. What is the relationship between the molarity and the molality? Now it has came. By here, now we got our formula. What? Now you see. What is the molality formula? Molality is equal to number of moles of solute by weight of solvent in gram into 1000 into 1000. Here already we have taken how much volume of the solution? 1 liter of the solution, right? Molarity is equal to number of moles of solute by V liter. We have taken this as a 1. Then the molarity will be equal to number of moles of the solute, right? In the place of this number of moles of the solute, can I substitute the molarity? I can. So molality will be equal to molarity into 1000. Done. By weight of the solvent in gram. What of the weight of the solvent in gram I got? Weight of the solvent in gram is equal to 1000 into density of the solution minus molarity into molecular weight. So can I substitute directly here? Weight of the solvent in gram, that is 1000 into density of solution minus molarity into which one? This is molecular weight of the solute. This is molecular weight of the solute. Don't get confused for which molecular weight we have to use. This is solute molecular weight we have to use. Okay. Now this is molecular weight of solute. Done. This is a one beautiful formula we are having. Based on this formula only, in the 2025 in the JEE mains we got the one question. So what is that one question? In the 2025 we got, now we'll see. This is a JEE mains 2025 we got based on that formula only. So instead of expanded formula, use that formula directly, you will get what? Molarity of 3 mole of NaCl they have given, and they are asking the molality. You can see they are asking the molality. So how to solve this one? And the density they have given. Directly put the molality is equal to molarity into 1000 by 1000 into density of solution minus molarity into molecular weight of solute. Done. Directly put this formula. Directly you put this formula and values you put. Molality is equal to 3 into 1000 by 1000 into density of the solution. How much they have given? 1.25 minus molarity. How much they have given? 3 into molecular weight of the solute. Molecular weight of the Na is 23 and chlorine molecular weight is 35.5. If you add, it will become 58.5. If you solve this one, you will get the answer. So what is the answer for this one? What is the answer for this one? Once you comment in the comment section. Okay. Now, mole fraction. Mole fraction. What is a mole fraction? Mole fraction we will represent with this chi. We will not say this as a chi. This is chi. Okay. Now, what is a mole fraction? Mole fraction means here ratio between number of moles of one component, to total number of moles of all component in the solution, all component present in solution. Clear? Now, here I was taking one solution. We are having the two components. Let is chi A. If I was saying this as a chi A, I was talking about the solvent, because we are talking about the binary solution, right? Binary solution, we are having only two components. A is representing for the solvent, and if I was talking about chi B means nothing but solute. Clear? Chi B means nothing but solute. Now what I will do, if I add chi A plus chi B, if I add mole fraction of chi A plus chi B, if I add that, it will give you 1. How it is giving 1? This relation we are going to use in our entire solution chapter. This formula we are going to repeatedly use. So how this chi A plus chi B is equal to 1 it has came. Now I will explain. Listen carefully. Done? Now what is the chi B formula? What is the chi B? Just now what is the mole fraction? Mole fraction, ratio between number of moles of one component to the total number of moles of all component of the present in the solution, right? Clear? Means number of moles of solute by total number of moles of solute plus total number of moles of solute, means number of moles of solute plus number of moles of solvent. If I was talking about the mole fraction of solvent, number of moles of solvent by total number of moles of solution, right? Clear? Or total number of all the components that present in the solution. Done? Now if I add chi B plus chi A, clear? What is the chi B? NB by NB plus Na plus Na by NB plus Na. Clear? Now this two, what it will give? NB plus Na whole square by NB plus Na whole square, right? I hope this maths you know. Clear? This 2 will get cancelled and it will give you 1. How many components you may add? Not only one. How many components you may add? Sum of all the components will give you 1 only. If you add 2, chi A plus chi B will give you 1. If you add 3, chi A plus chi B plus chi C will be equal to 1. Clear? If you add 1 also 2, it will give 1. If you add 3, it will give 1 only. Clear? Now here, after that, just now we have seen what is the relationship between what is the relationship between molarity and the molality we have seen. Now we are going to see this relation repeatedly we are going to use in our solution. So listen carefully this converse. Relationship between the molality and mole fraction. Relation between molality and mole fraction. Molality and the mole fraction. Now you see, what is the relationship between the molality and the mole fraction? Here, what I was taking, chi b by chi a. Chi b by chi a. What is the meaning of chi b by chi a? Chi b is nothing but nb by n total, na plus nb. Okay, I will take na plus nb by na by na plus nb. Then this na plus nb and na plus nb will be get cancelled. Then this formula will be nb by na. Means, can I say chi b by chi a will be equal to nb by na. nb by na. Clear? Now remember this one. Now with this relation, how we are going to relate the mole fraction and the molality? How we are going to relate the mole fraction and the molality? Okay, you may get it out, sir. Why you have taken the chi b by chi a? A by chi b we got. Now we'll see. Here, chi b by chi a is equal to number of moles of solute is weight of solute by molecular weight of solute by weight of which one? Solvent by molecular weight of solvent. What it will give? This will give you weight of solute by molecular weight of solute into molecular weight of solvent by weight of solvent. Clear? Chi b by chi a, what we got? Weight of solute by molecular weight of solute into molecular weight of solvent by weight of solvent. This we got. Okay, up to now you remember this one. By this one, how to relate it with the molality, now we'll see. With this one, with this formula, how to relate with the molality, now we'll see. Chi b by chi a is equal to weight of solute by molecular weight of solute. For our mathematical calculation purpose, I was taking the 1000 in the numerator and the 1000 in the denominator by weight of solvent, right? This is weight of solvent into molecular weight of solvent by 1000 can I take? By 1000 can I take? Clear? By 1000. Here 1000 if it is get cancelled, the same formula it will be repeat, right? Now you see this formula, where we have seen this formula, weight of solute by molecular weight of solute into 1000 by weight of solvent, right? This is weight of solvent in grams. This is nothing but molality formula. Here we have seen, where we have seen this formula, molality formula. See, weight of solute, molecular weight of solute into 1000 by weight of solvent in gram is the molality, right? Clear? Now, then chi b into chi a is equal to molality into molecular weight of A by 1000, can I say? Clear? Now you see what is the beautiful relation that we got between the mole fraction and molality. Mole fraction and the molality. Sir, how the questions they will ask you on this relationship between the chi a and the molality, sir? Now see, one question will do. Clear? This is on the basis of molarity and the molality. See, mole fraction of a solute in aqueous solution is 0.2. The molality of the solution will be is asking. Molality of the solution will be is asking. Now you see, data they have given on the basis of mole fraction, and they are asking the answer in the molality. Just now we got the one relation, right? What is the beautiful relation we have seen? Chi b by chi a is equal to molality into molecular weight of solvent by 1000. Okay, sir, Here there is no any chi B. Here there is no any chi A. There is no any molecular weight of the solvent they have given. Sir, how I can calculate and how I can get the answer? Okay, my dear students, now listen carefully. Whenever this type of the question they have given, the data they have given, here they have taken it as a aqueous solution. What they have taken? Aqueous solution. Yesterday I was explained in the first video very beautifully. If the solvent is water, that solution we call it as a aqueous solution. Aqueous solution means nothing but, aqueous solution is nothing but solvent is water. Solvent is water, that you have to remember. So molecular weight of the solvent A is 18, from here we got. So molecular weight of the A we got from here. Next, sir, here he has given only one data. Mole fraction of the solute is 0.2. Mole fraction of the solute is 0.2. Means one beautiful relation we have seen, right? Chi A plus chi B will be equal to 1. This is mole fraction of the solute. This is a mole fraction of the solute. Clear? Mole fraction of the solute, if they have given 0.2 means mole fraction of the solvent will become how much? 0.8. Katam. All the data we got. Now you solve the molality. How to solve the molality? Chi B how much you got? 0.2 they have given. Chi A how much they have given? 0.8. From here we got. So molality you have to calculate. Into molecular weight of the solvent already we got. Here it is 18. And if you divide it by the 1000, now if you solve this one, you will get the answer. Now what is the answer of this one? Once you comment in the comment section. Clear? Now I hope now we have seen what? Many interconversion formula which are very important for the calculation purpose, and it is very important to solve the which questions of our solutions. Now what are the formulas that we have studied? Once we will recap very fastly. Okay, first is molarity. What is the formula of the molarity? Molarity, number of moles by volume in liter. And one important formula that we are going to see in the which one? Molarity is weight of solute. Weight of solute is equal to molarity into volume of solution ml. Volume of solution, what? Volume of the solution in ml into molecular weight of solute. Molecular weight of the solute by 1000. This is a one formula we have seen. And the next very most important formula we have seen, molarity is equal to what? Weight by weight percentage into density of solution into 10 by molecular weight. Clear? Done? This we have seen. Next one. Next formula. We have seen normality. What is the normality? Gram equivalents by volume in liter. So N is equal to one important formula also we have seen, molarity into N factor, and gram equivalents or equivalents is equal to number of moles into N factor we have seen. And one important formula we have seen, normality is equal to weight by weight percentage into density of solution into 10 by equivalent weight. This is a one beautiful formula we have seen. Clear? Next formula we have seen, relationship between the molarity and molality. So molality is equal to molarity into 1000 by 1000 into D of solution minus molarity into molecular weight of solute. Clear? Done? This is a one beautiful formula we have seen. Then after that, next what we have seen? Mole fraction. Chi A plus chi B will be equal to 1. And the relationship between molality and the mole fraction, chi B by chi A is equal to molality into molecular weight of solvent by 1000. Clear? These are the some beautiful formulas that we have seen. Clear? Now here what we are going to, now we have seen the all the formulas and how it has came and how it has been derived, right? Okay, based on these formulas, I was given the some questions. Okay, I was given some questions. Try to solve it from your own. Whatever the formulas I was given, try to solve it for your own. For this question solution, I will give you in the next lecture. Okay, this question solution we will discuss in the next lecture. What you do better, once you, while you are solving, use the, write the formulas and what is the data they have given and what they are asking. Clear? Now you can see this questions. When you are solving, try to pause the video and solve. Okay, now which of the following quantities are temperature dependent? They are asking direct question, normal question. Which of the following quantities are dependent on the temperature? Which one? Molarity will be depend upon the temperature because N by V. Normality also will be depend upon the temperature. Equivalence by V liter. Clear? Mole fraction will not be depend upon the temperature. Why? Because mole fraction is a depend upon the weight, and molality also will not depend. These two will be depend upon the temperature. Which of the following quantities will be depend upon the temperature? And these two quantities will be independent of the temperature. Okay, now these three questions, one. Okay, while solving, pause the video and solve. Next, this is 2. Okay, and this is 3. Okay, now these three questions solutions I will explain in the next video. Okay, bye, and we'll see you in the next lecture.